So hello everyone, welcome to the channel. So in this video, we're going to focus on getting started with basics of JavaScript in Google Earth Engine. So we're going to focus on exploring basic image collection, filters, and viewing the image collection and analyzing in Google Earth Engine. So now let's get started. So first we're going to focus on how to view an image. So we're going to use the Landsat 8 image for this particular tutorial. So let me show you this particular the satellite image we're going to use. So this is USGS Landsat 8 Level 2 Collection 2 Tier 1. So the data availability is from 2013 to 2024 and the dataset provider is USGS. So these are the following bands that is available in this particular satellite image. So the resolution is around 30 meters of resolution. So you can able to view this set of bands here. So now let me get back to the Earth Engine. So first we're going to import the Landsat 8 raw collection into Google Earth Engine. So to do that, we're going to define this variable called Landsat 8 equals to image collection Landsat LC08 C02 T1. So this particular code is used to import our Landsat 8 image collection to Earth Engine. So this is the code we're going to use for this to access this particular satellite image. So next we're going to print this collection size here. So to do that, we defined as a print collection size. So for that, we define this print. The size of the Landsat 8 image collection is, so we defined as Landsat 8 dot size. So the Landsat 8, which refers to this particular variable, which importing our Landsat 8 image dot size function. So we are using the size function to display the total number of image in the collection in the console. So this helps us to understand the volume of data you are working with. So to do that, we define this as a Landsat 8 dot size function. So we can also attempt to print the entire collection of collection image. So to do that, we define print Landsat 8. So avoid using this because it will introduce this particular error called uncommenting this line could cause an error as the console cannot handle more than 5000 elements. So we can see that here. So let us visualize it more here. So now let me run this code here. So we're going to run this particular script 2 and 3. So these 3 code, we're going to run this. We're going to navigate to this option called run and click run. So now in the console section, you can able to visualize using our size function. So we're going to calculate the total number of, which helps us to understand the volume of data we are working with. So you can able to visualize here, we have this error I have mentioned earlier. So which states that the collection aborted after accumulating over 5000 elements. So to avoid this particular error, so I'm gonna not use this particular code here. So it will take some time to visualize the total volume of the dataset that is available. So we can proceed further here. So now here you can able to visualize the size of the Landsat image collection is given here. So the total number of Landsat 8 image collection is around 18 lakhs 86,041 Landsat 8 image collections that is available. So you can able to visualize the total volume of data we are working with here. So next we're going to focus on displaying the image collection as a mosaic, as a true color composite. So to do that, so we're going to use these three bands, that is B4, B3 and B2. So let me show you the B4, B3 and B2. So B4, which represents the red band, and B4, so the B4 which represents the red band, and the B3 which represents the green band, and the B2 which represents the blue band. So together, on compositing these 3 bands together, it's gonna give us a true color composite, that is the natural color composite. So to do that, we defined map.addLayer Landsat 8. We are referring to our Landsat 8 image collection we are mentioned as here, and in that specifically we are using this curly bracket in order to mention the bands that we're going to use this for this to mosaic and create a natural color composite. So for that, we mentioned as the bands here, and we are taking this particular set of bands B4, B3 and B2, and we are setting the minimum and maximum value. So the minimum and maximum value which represents the brightness and the contrast of the image. So you can able to visualize from here, we have given the minimum and maximum value for this image. So minimum is around 1 and the maximum is around 65,455. So we are getting a service, taking a suitable range here, that is a minimum of 5,000 and a maximum of 15,000, and output the layer name as Landsat 8 image collection. So now let us run this code again. We're going to navigate to this option called run and click run. So in the layer section, we're going to navigate here. So this is the layer section here. So let me mention another code here, that is we're going to mention. So the image is getting loaded here. Make sure that you mention this code map.addLayer, that is map.center object. So now mentioned as the map.center object Landsat, referring to a Landsat image, and we have mentioned the zoom level. So I'm gonna run this code again. So the map.center object has introduced some error here. The user memory limit exceeded. So let us void this particular code. And again, I'm gonna run this. So now in the console section, it is loading the size of the Landsat 8 image. So we're gonna visualize the true color composite of this particular Landsat 8 image. So let us visualize that. So it is loading the layer here. So now here you can able to visualize here. So it is loading all the Landsat 8 image here. So it's gonna load all the Landsat 8 image in true color composite. So it's gonna take some time here. So you can able to see from this layer section, it is currently loading all the Landsat 8 image in true color composite. So now next we're gonna focus on filter by date. So the next set of operations we're gonna do is filter by date. So we're gonna filter the image collection by date. So to do that, first we're gonna filter the Landsat 8 image collection for the winter image. So during December 2020 to March 2021. So to do that, we define this variable called Landsat winter equals to Landsat dot filter date. So the Landsat 8, which refers to a Landsat 8 image collection, and we're gonna apply this filter function in order to filter the specific timeline. So for that, we define dot filter date 2020 December 1 and 2021 March 1. So next, to add the filtered winter collection to the map, we defined map.addLayer Landsat winter, which refers to this particular variable. So in this variable, we have applied the filter function for the specific timeline, which is referring to this particular variable called Landsat winter. And in that, we're gonna use this set of bands, that is B4, B3, and B2. That is B4, B3, and B2, red, the red, green, and blue band, with setting a minimum value of 5,000 and the maximum value of 15,000, which represents the brightness and the contrast of the image, and output the layer name as winter Landsat 8. So now to print the filtered collection size, so to view the total number of image collection that is available for this specific period, that is from December 2020 December 1 to 2021 March 1. So to view that, we define this print number of image in winter Landsat 8 collection, and to view the number of image collection, we define Landsat winter dot size function. So using the size function, you can able to calculate the total number of images that is available for this particular timeline, that is this particular timeline. So let us visualize that. So to do that, we defined, we're gonna navigate to this option called run and click run. So in the console section, you can able to visualize it is loading the number of image in winter Landsat 8 collection. So it is around 33,082 images that is available during the December 2020 to March 2021. So you can able to visualize the number of images that is available in the winter Landsat 8 image collection, which is around 33,082 images available in this specific timeline. So next operation is we're gonna focus on filter by location. So to filter by location, first we need to define the geographic point in so to filter by location, so we are going to define a geographic point in Minneapolis, USA. So to define a geographic point, it is simple. We have to define the latitude and longitude. So to do that, we define this variable called point MN, which is referring to this particular study region, Minneapolis, and variable point MN equals to geometry.polygon, geometry.point, and latitude and longitude of that particular location. And once you entered the latitude and longitude, we're gonna navigate to this next step here. So we're gonna filter the winter collection for the image covering the Minneapolis. So to do that, we define the variable called the Landsat mn equals to the Landsat winter dot filter bound point mn. So we are using this filter bound function in order to focus on this particular point, that is this particular latitude and longitude or a geographic point. So for that we are using this specific function. So dot filter bound point mn, which represents this variable containing latitude and longitude. So next we're gonna add this location filtered collection to the map. So to do that, we define the map.add layer Landsat mn. So the Landsat mn, which represents this particular variable. So we are using this variable, we have filtered filter bound the point that is geographic point. So to add the location filtered collection to the map, we are using this particular variable here. So map.add layer Landsat mn, and in that we are using this set of bands, band 4, band 3 and band 2, that is red, green and blue, and we are setting a minimum and maximum value, which is around minimum of 5000 and the maximum of 15,000, so which represents the brightness and the contrast to the image, and output the layer name as mn Landsat 8. So now to print this image and view the number of image that is available for this particular geographic point, that is our latitude and longitude for this specific study region, Minneapolis. So to identify the total number of images that is available on this specific geographic point, we define print number of images in Minneapolis winter Landsat 8 collection, and we are adding this Landsat mn dot size function. So I have already mentioned the size function is used to calculate the total number of that is available, there is a total number of images that is available for the specific geographic point. So to do that, we're using the size function. So now let us run this code. So we're going to navigate this option called run and click run. So now in the console section, we have this number of image that is available for Minneapolis and winter Landsat Landsat 8 collection. So total number of images that is available are 7. So the 7 images are available for this specific geographic point. So you can able to visualize the image here. So it's currently loading the image here. So we have 3 different layers. Starting, we have see the Landsat. Next, we have filtered based on the. So the second, we filtered based on the date, and the third, we have filtered based on the geographic point or the latitude and longitude. I'm gonna turn this off here. So we're gonna focus only on the specific layers here. So we're gonna navigate this set of layers. So we have a lot of images here. So let me turn off this second layer too, the winter collection. We're gonna focus on the specific the geographic point, which is located in USA, United States. So Minneapolis, you can able to visualize. So the total number of images that is available is around 7 for this specific timeline. So the next step of this procedure, so we're gonna selecting the first image. So out of the 7 image that is available for this specific study region, so we're gonna select the first image. So out of 7 image, we're gonna select the first image in the Minneapolis winter Landsat 8 image collection. So to do that, we're gonna show you that. So to do that, we're going to define a variable. So first we have to select the first image from the Minneapolis winter collection. So this is our layer containing all the 7 images over this specific study region, that is Minneapolis. So to do that, we define this variable called Landsat first equals to the Landsat mn, which represents the images we filtered based on the geographic point. And in that there is around 7 images, and now in that we're going to select the first image. So to select the first image, we defined first function. So to select the first image, we define dot first function. So the first function, it retrieves the earliest image from the filtered collection. So for that, we define variable Landsat first equals to Landsat mn dot first function. So next we're going to center the map on this image and display it. So to do that, we define map.center object Landsat first, referring to this particular variable with a zoom level of 7. So last, to add this first image, to view this first image, so we're gonna mention as a map.add layer. So we are referring Landsat first, and the bands we're gonna use is B4, B3 and B2. So which gonna give us a true color composite, the natural color composite, and with a minimum of 5000 and the maximum of 15,000, the brightness of the contrast of the image, so which is the suitable color. So next, output the layer name as first Landsat 8 image. So to view this image, we're going to navigate to this option called run and click run. So now let us visualize the first image. So I'm going to turn off the other layers. We're going to focus only on this particular first image. So now we can able to visualize here. We have our first image, that is our Landsat 8 image over the specific study region, Minneapolis, USA. So let us visualize in true color composite. We're going to navigate to the layer section here and click this option. And in that, we're going to select three bands RGB. So we have selected B4, B3 and B2. And the custom, I'm going to click as stretch 90%. So it's going to apply the contrast of the image correctly. And going to apply it. And let us visualize the image here. So currently we are visualizing this image here, so which is in true color composite here. So due to the presence of this cloud contamination, so you can able to see that we have a lot of cloud contamination here. So let me close this. So we have a lot of cloud contamination over this particular image collection here. You can able to see that. So in this video, so we have explored the basic image collection, filter, and viewing and analyzing in Google Earth Engine. So in our tutorial on getting started with basics of JavaScript in Google Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like.